All right, so this is video 3 on graphing, and we've already done several of these using these steps, rewriting in function form, making an input-output table, and then drawing a line through our 3 points after getting those coordinates. Let's jump to the ones we haven't done yet. Number 3, we're going to get y by itself first, rewriting it in function form. That's the first step. So I need to get rid of everything except the y. So y is the movie star, 2 is the movie star's buddy, including the minus sign. This guy we want to get rid of first. So let's get rid of that plus or positive 6x by subtracting 6x. What you do to one side, you do to the other, subtract 6x. You're going to have a new equation that reads negative 2y equals, so you can't really subtract 4 and 6x. So we're going to rewrite it. But instead of writing it 4 minus 6x, we might as well write the x term first, negative 6x, and then the positive 4 second. We're going to have to do that in the future anyway. So we got rid of the 6x. Now let's get rid of that negative 2 that's being multiplied by the y. So how do we get rid of the multiplication of negative 2? Divide it by negative 2. And when you do to one side, you do to the other side. So we're going to divide everything by negative 2. This guy by negative 2 and this guy by negative 2. Everything by negative 2. So my new equation, which is my final function form equation, y is by itself. That's what I wanted. Negative 6 divided by negative 2, that's a positive 3. And of course, there's an x with it. And the last term, a positive 4 divided by a negative 2, that's a negative 2. And this has y by itself. This is a function form equation. Now I could worry about making an xy table, an input-output table, and plugging in 3 easy numbers. Let's start with 0. That's the easiest one. We're going to plug in 0 right into the x. Why? Because it's on the x side. The x's are the inputs. We're plugging in 0 for x. So we're going to have 3 times 0. Let me write it out. 3 times 0 minus 2. So 3 times 0, that's 0. And 0 minus 2 is negative 2. So when I plug in a 0, I get out a negative 2. And that is a coordinate. Let's go to the coordinate 0, negative 2. 0 on the x, negative 2 on the y. There it is. Let's plug in another number, which is another easy number to plug in. 1. So when I plug in 1, what do I get? I have 3 times 1 minus 2. What's 3 times 1?
3.
That's 3. And what's 3 take away 2? 1. So we get out a 1 when I plug in a 1. So I go to the coordinate 1, 1. 1 on the x, 1 on the y. I end up right here. And that's already good enough to draw my line. You could use the pattern to get to the next point. If you wanted to, you could say, okay, from one point to the other, I went up 1, 2, 3 over 1. So if I go up 1, 2, 3 over 1, I should end up right there. But I don't want you to just use the pattern. I want you to actually plug in the next number, which would be 2. And when you do plug in 2, you'll get 3 times 2 minus 2. And 3 times 2 is 6, and 6 minus 2 is 4. So we really do get the output 2, 4. And if I do go to 2 on the x, 4 on the y, I really do end up right there. So using the pattern or using algebra, you end up right here anyway. So let's connect our dots, put some arrows on it, and we are good. We've graphed it. Let's move on. There's only 2 left. Number 4, that one's pretty easy. What do I do to get it in function form? Minus 5. Let's go minus 5 here, minus 5 there. You can't really subtract 5 from 3x's. So we're just going to rewrite it. Y equals 3x minus 5. And this is now in function form. And now we could go for an xy table. And now we could plug in 3 easy numbers like 0, 1, and 2. And when we plug in 0 right into the x, 3 times 0 is 0, and 0 take away 5 is what? 0 take away 5 is what?
Negative 5.
Negative 5. Thank you, Crystal. Let's plug in 1 right there. 3 times 1. 3 times 1.
3.
What's 3 minus 5?
Negative 2.
Negative 2. And then plug in 2 right there. What's 3 times 2? What's 6 minus 5?
1.
1. So we did all this without showing work. I don't recommend it. But we do have our 3 answers. How many answers exist? Infinite, right? You could keep going forever. You don't even have to plug in 0, 1, and 2. You could plug in 3 if you want. If I did plug in 3, 3 times 3 is 9, and 9 minus 5 is 4. I could plug in 4 if I want. I could plug in 10 if I want, right? 3 times 10 is 30. 30 take away 5 is an output of 25. All of these points are answers. All of these points land on the line. But the easiest ones are 0, 1, and 2, especially because there's no fraction in front of the x. So let's graph 0, negative 5. 0 on the x, negative 5 on the y. It's right here, right on the edge. 1 and negative 2. 1 on the x, negative 2 on the y. It's right here. 2 and 1. 2 on the x, 1 on the y. It's right there. And let's connect the dots. Let's draw some arrows, and we are good. Now, if I went to the coordinate 10, 25, think about that. If I went 10 on the x, 3, 4, 5, 6, 7, 8, 9, 10, then went 25 on the y, that would land perfectly on that line. So this line really does represent the infinite amount of answers. Last one. We want to get y by itself. What do I do first? Plus 25. Thank you, Angel. What you do to one side, you do to the other side, but you cannot add 15x with 25, so what are we going to do? Just rewrite it. Thanks, Ricky. We're going to end up with negative 5y equals 15x plus 25. You just rewrite it. Final step. Divide by negative 5, divide by negative 5, divide by negative 5, and now we have our function form equation. Y equals negative 3 with an x minus 5. That's your function form equation. That's step 1 on the steps I gave you. Now you want to make an XY table next, an input-output table. We're going to plug in 3 easy values like 0, 1, and 2. I recommend showing the work, but I'm just going to go right here in our heads. We're going to go 0 right into the x. 0 is the input. Negative 3 times 0 is 0. And 0 minus 5 is minus 5, negative 5. When I plug in a 1 right here, what's negative 3 times 1? And what is negative 3 minus 5? Yeah, you owe 3, you owe 8. I mean, you owe 3, you owe 5, you're going to owe 8. And right here, last but not least, 2 right in there. Negative 3 times 2 is what? Negative 6 minus 5, negative 11. Now let's graph these guys. 0, negative 5. 0 on the x, negative 5 on the y. There it is. 1, negative 8. Where's 1, negative 8? 1, negative 8. What? We're off the graph, guys. We are off the graph. So what if I wanted to be on the graph? Yeah, let's instead of plugging in, like right here we plugged in a 1 and a 2. A 1 gave us this, and if I plug in a 2, it's going to be even further down. So instead of plugging in a 1 or a 2, let's plug in a value of x that's on this side, like a negative 1. So let me do this right here in black. I want to plug in a negative 1 for x. And if I did plug in a negative 1, it's going to read negative 3 times negative 1 minus 5. So what's negative 3 times negative 1? That's positive 3. Positive 3 minus 5? Negative 2 is the answer. So when I plug in a negative 1, I get out a negative 2, and that is on the graph. Negative 1, negative 2 is right there. Now, do I need to plug in more values if I want it to go this way? I could if I wanted to, but what other way could I do this? With the pattern. So if from here down to here, it's down 3 over 1, going backwards is up over 1, up 3. So I could go up 3, 1, 2, 3, and over 1 this way, bless you, and put a dot right there. Then I could go up 3 again, over 1 this way, put a dot right there. You could make the line as long as you want. Draw, that's an ugly line, sorry. Draw some arrows on it, and you're done.